Morning to all. I'm Sajivan, President of Civil and Environmental Engineering Society, University of Jaffna, and I want to invite all to the online free webinar session on Civil 3D. And today the host of the event will be Miss S. V. Vinusha, and I transfer the session to S. V. Vinusha. Over to you, Vinusha.
Thank you, Sajivan. Am I audible to you all? Am I audible?
Yes, audible.
Yeah. Very good morning, dear participants, my fellow mates, and our dear resource person, Engineer Mr. Shrijen. I'm Inusha from Faculty of Engineering, University of Jaffna. Once again, I warmly welcome you all on behalf of CEES Jaffna. It's a great pleasure to meet you all today, and today's session will be an introduction to Autodesk Civil 3D. Although civil engineering aspects include a variety of softwares, Autodesk Civil 3D supports workflow for various civil engineering projects, including roads, highways, rail, bridges, tunnels, site development, and structural and sanitary works. Today's session will be covering the introduction part by our dear resource person, Engineer Mr. Shrijen. Engineer Shrijen completed his undergraduate degree from Faculty of Engineering, University of Rohuna, and he worked in Engineering Services Private Limited, and currently he is working as a highway design engineer at Sun Constructions. As well as he's a freelancer working for a lot of reputed foreign-based companies as a design engineer. So we are very glad and honored to have your presence, sir, and we warmly welcome you once again. Earlier, we planned to conduct this webinar in 2 sessions, but unfortunately, due to some technical issues, we are planning to have it as 1 session, but in 3 hours straight, including question and answer session also. So hope you all will make this moment profit and happy learning to all. So without any further delay, let's start today's session. Over to you, sir.
Thank you very much for your wonderful introduction about me. Don't be delay. Let's move to the session. Okay. I will share my screen now. I hope you all of you see my screen now. This is the basic interface for the Civil 3D. Before going to this session, all of you need 2 requirements for learning about Civil 3D. You need to know about the basic understanding of the AutoCAD, and second one is you need to use your common civil engineering practice to design something in this software. So these are the main 2 requirements to work on this software. I give some introduction about the Civil 3D. This is an Autodesk product. So all the AutoCAD commands work on AutoCAD Civil 3D also. And also you can, a lot of engineers are using this software for various purposes. For example, stormwater engineers, surveyors, road engineers, highway engineers, surveyors, draftsmen, quantity surveyors. So various professionals are using this software for various purposes, for planning the stormwater network, site grading and planning, intersection design, and subdivisional plan. So it have more powerful software for any civil engineer aspect. So every civil engineer by using this software, every engineer got more benefit by using this software. So these are the small introduction about this software, and also it's very tough to teach you within the 3 hours. This whole software is very tough. So I'm going to introduce some of the common and basic tools by using this session. Okay, let's move to this session. This is the basic interface. I'm using the Civil 3D 2022. If you are using the lower version or upper version, you can see some little bit different interface. some interface, meaning some tabs and the tools are not appear, or you will have some more tools if you are using the upper version. So these are the similar thing. Basically, if you're using the about 2014, you can get this kind of ribbon version. Ribbon version means you can see like this kind of tabs appear. If you are using the below 2014, it's something like classic version. It's very old version. So currently we are not using this classical version. Now we are move on to this ribbon version. First, this is our application menu. In this menu, you can see all the software have some common tools. Opening a new document, open the existing document, serve the document, serve a copy of the document, and export some other file format like that. The all softwares have some kind of similar tools. In Civil 3D also, you can find those tools in the application menu. And this bar called Quick Access Toolbar. I will share some PDF also in the group, and you can get that PDF also. I will add some points for this application menu, this toolbar also, you can find it. This menu is called Quick Access Toolbar. In this access toolbar, you can find, wait a minute. in the top left side, you can find the Quick Access Toolbar. By using the Quick Access Toolbar, we can access the more frequently used toolbar like open, serve, print, like that. We can customize this toolbar as per our wish. This is workspace. If you are using the Civil 3D, we don't need to install the AutoCAD also. We can easily switch on to AutoCAD by using the drafting and annotation window. That is called the workspace. So you can easily switch back to AutoCAD, and also you can easily switch back to Civil 3D also. So if you have Civil 3D, don't need to install the AutoCAD. Then I move to Civil 3D. In the top middle bar, you can find out my drawing name and the AutoCAD version. I'm using the 2022. I mean drawing 2.dw version. And if you have a Google Autodesk account, you can sign in here. And also you can find more tabs here. These tabs are very useful to find out a tool. It means all the tools are set up in a meaningful tabs. If you are going to insert any, for example, if you are going to insert any picture, you go to the insert tab and you can find this attach. In this attach, you can, for example, you can attach any image. So like that, every meaning, comb, insert, annotate, it means a meaningful name. In the meaningful name, you can find out the tools. These all of for ribbons. Each tool we can discuss in later. One of the more important bar is called this command bar. This command bar is very useful. Always is prompt to you the next step for your work. It means it says what is your next step. So always remember to look at this command bar. And also this status bar is called status bar. If you are familiar with AutoCAD, you can find out this similar bar, this auto, grip, and snap mode and line weights. All of this is the basic thing for AutoCAD. If you don't familiar with that, please go and try to understand this one. Okay, and also it have two windows. The first one is model. All the drafting works are we need to done it here. And the second one is the layout page. In the layout page, we are doing the printing works. Normally, we are all the printing works used to create this layout sheet. In the layout sheet, we are done with the papers. First, we fix the papers A4, A3, A3. First, we need to fix the paper side and add the title box. And after that, we need to do our printing work. This is the workflow for a output document. Okay. For interface, I give you a small introduction, and also you can see some tool palettes are attached in the left side. These all are, this first one called properties. If you are not find it, type PR and press enter. So in AutoCAD, in the Civil 3D AutoCAD, we can work in two manner by using the mouse, and second one is keyboard manner. If you type PR and enter, you can find out the properties. It's a AutoCAD properties window. If you don't, if you are like to work in the mouse and go to the view, and you can find out this button for the tools. It will show up your tooltip. In the tooltip, you can find out what is that the tool name and what is the shortcut. You can see Control+1, you can accessible for the properties. So like that, one of the important tool palette is this properties, and second one is layers. Sorry, this is tool space. This tool palette is only dedicatable tool palette for the Civil 3D. You can't find in you can't find in the AutoCAD. It's only dedicatable tool for Civil 3D. We will discuss about these tools in later sessions. This one called layer properties. If you type LA, then you can find the okay. I hope I will give a good introduction about the Civil 3D interface. Then we are going to start our Civil 3D dedicated tool. I'm going to introduce a Civil 3D dedicatable tool. First points. You can see in the create design tab, you can see parcel, feature line, grading, alignment, profile, corridor, introduction, assembly, and pipe neighbor. These are called civil object. So each civil object have two type of styles. It's mean first one is object style. Wait. Just think about the point object. This point object have two styles. One for object style. Second one is label style. This is the way of this software is programmed. So each civil object means the parcel, feature line, grading, alignment, from like that called is the civil object. Each civil object have a separate object style. It means profile have a separate object style, and corridor have a separate object style. Each object have a label style. It's mean in engineering concept, it is must we have to provide a proper labeling for all design works. If you are doing a structural work, we need to mention the beam B1, B2, B3, like that. It is called that label. So like that also Civil 3D also provides some labels. It automatically give us. We are not going to create manually. It will give automatical labeling process for labeling steps. So each Civil 3D object have object style and the label style. These are not manual one. It will create us automatically. Just we need to create the civil object only. It automatically give you the object style and the label style. Okay. Okay. These are the things. And before go to the auto Civil 3D points, there are in the points type, you can find 2 points. The one is AutoCAD points. The second one is Civil 3D points. Civil 3D points mean COCO points. It have a dedicated name that is called COCO point. Civil 3D points, we can call it as COCO points. What is the difference between the AutoCAD points and the Civil 3D points? The simplest way of explaining this AutoCAD points and the Civil 3D point is AutoCAD points have less information. Okay, AutoCAD points have less information, but Civil 3D points have more information about the points. And also it have some object style and label style. But in the AutoCAD points, we don't have anything. So these are the main reason for AutoCAD points and Civil 3D points. So now I am going to insert the AutoCAD points and Civil 3D points and give a overall idea about these two things. So for inserting a point, AutoCAD points, just type POINT point and press enter, and you can get the point tool. And then it is asking for a specify a point. Just I locate a point for my points and type point edit, P type, and increase that. Sorry, change the point marker style. So then I get a visible point, AutoCAD point style. If you click this point and you check with the AutoCAD property, and you can get this as a point. It's a AutoCAD points. Okay. Now I'm going to insert a COCO points by using this point tool. So it's a dedicated Civil 3D point. So just click this drop down and go to the point creation tool. In the lot of Civil 3D object, you can get this kind of flyover toolbar. This toolbar called flyover toolbar. In the right side to left side to right side, the tool complexity is increasing. It means we using this tool is very easy, but using this kind of tool is little bit tougher. So likewise, all the Civil 3D object are Civil 3D flyover toolbars are created in like that manner. So now I'm going to insert a COCO point. So click the drop down and go to the manual and click it. And it is asking for a point location. So I just click this point, and it asks for a point description. So I'm going to give a description random. Just type random and press enter. You can give anything in the point description as per your wish. So and press enter. And next step it asks for elevation. So I'm just give the elevation for 1000 and press enter, and it will place a COCO points. To check that, I click my COCO points and come to the AutoCAD property. It will say it's a COCO points. So now I have inserted a AutoCAD point, and next one is a COCO points. You can see if I click the AutoCAD points, you can see only it have the X, Y, Z direction of data. It's been what is the X coordinate data, Y coordinate data, and Z coordinate data. And these are the layer properties details. But if you go with the COCO points, you can see some more data. So what is the point number, what is the row description, what is the style, and what is the point style. And also you can find some more details for this COCO point. So this is the main difference in the AutoCAD points to Civil 3D points. So this is the main difference. I hope you will understand a difference between the AutoCAD points and the Civil 3D points. So in the Civil 3D platform, we are always using the COCO points for my its various purpose. It is very easy to use. We can customize these point groups and points labels as per our at one shot, we can change any style and any point label style. So, or it's very preferable to use the AutoCAD point style, AutoCAD Cocoa points rather than using these AutoCAD points. So just I'm going to remove these things. Okay. Now I'm going to import some points to create a surface. So before creating that surface, and again go to the point tool and click the point creation tool again. In the tool palette, there are more tools out there, so I can't give more explanation about each and every tool. So I'm going to talk about the only important tools. So now I'm going to import the point. So just click this button and it will redirect to my file explorer. So I'm going to show my file folder. So just click this file for add file, and in this file, you can see in the file name, I will click this plus button to reach my file folder. My file folder in this CSV format, but in the file tab, you can see it is text format. That's why it is not showing anything in this dialog box. So if I want to change if I change that to CSV, I will find my file. So, and also, if I going to add some files to this import dialog box, it must be a CSV file or text file or PRN file. N is that like file. These files we need to give that to this import file. But commonly we are using the text file and the CSV file. These are the most common files to import file type. So first I give the CSV file type and get the file and press open. And you can see there is a green color tick mark. This tick mark showed there is no any issues with the file. It successfully imported into here. And also we need to give some more details about this file also. So Civil CD asking specify file format. It will ask the file format. So before that, I'm going to open my file to something. I hope all of you see my Excel sheet, I think. This Excel sheet totally have 607 points are there. The first column represent the point number. The second one is represent the east coordinate. East coordinate means the X direction. Second one is the north direction. North direction means the Y direction. In the fourth column represent the elevation. It is the Z direction. The last column is the description. Normally these data are given by our surveyor. Surveyor went to the site and do the surveying work, and they give the points and points number and the coordinate with the elevation, and also they given the elevation. If you did your survey camp, and all of you know about these things. NS mean they took the description for natural surface. Tree means tree, it's the same word. So NS means it's a natural ground. It means the existing ground detail. So these are the detail inside that file. So these are the data we are going to import properly. So again, I close this window. And you can see it is perfectly successfully imported. Then it will ask for the questions. What will be the file format? So I'm going to select, you already show it. The first one is point number. Second one is east coordinate. Third one is north coordinate. So I need to find out the same file type. So first here you can find point. P means the point number, N means the north coordinate, but our first one is east coordinate. So I need to go with the next option. here you can see. First one is point description, second one is east coordinate, third one is north coordinate. That means the elevation, D means the description. So, and also you can find out a small preview for your file format. Point number, east coordinate, north coordinate, point elevation, row description, also perfect. If you are going to add into the point group, you can click this. We are not talk about the point group yet, so we will in a couple of minutes we will talk about the point group. So therefore I am not going to give any point group for these points. Then press OK. So I successfully imported my points into that drawing file, but we haven't seen anything change in my window. So you see, just think about this is our larger AutoCAD window. In this larger AutoCAD window, we are just seeing this much of window. Our points are imported somewhere here. So if you are going to see that points, we need to move our window here to there, here to there. If you move our window here to there, then we will see our point. So therefore, zoom extend come into play. So I'm going to use the zoom extend command. If you are familiar with AutoCAD, then you will know about the zoom extend command. Type Z and enter and click the extend, and you can find out all the points. In a one shot, we can import 607 points at a one click. So these are the things that's why the Civil 3D is more powerful software. So if you click that one point, you can see this is a cocoa points. If you click any Civil 3D object and you can change at the top, there is a new tab that is called conceptual window. It will work for all Civil 3D objects. So if you click in any Civil 3D object, the top ribbon bar should change. It will give a prompt. It will guess our next step and give a similar tool or related tool to the Civil 3D object. So if you click that point, you can see point group properties. If you are going to change any point group properties, you can come here and change the styles and point label also. For as of now, I'm going to change the description only. And you can see in the first case, we are not having any description for our points. At one click, I will change, I will add each and every points for the point description. One more thing. For understanding the software, this is an important thing. In the point, you can find two objects. One is the point marker style. Second one is the point label style. So these two things are created this point group properties. So again, I just click my point and go to the point group properties. And you can see, I already talk about the point group, point style, and point label style. So these two different style, one for the exact civil object style and second one for the point label style. So in this case, I give the point description. If I need to change anything, just I click that drop down and go to the elevation only and press apply OK. Then all my cocoa points will change. So if I'm going to do with AutoCAD, I just go and manually place a elevation for each and every point. It's very time-consuming method. But in this case, I just think about it. I just created this drawing and submitted to my client, and they are asking, I need the description also. If I going to change this to description also, I need to change to 607.9 manual for AutoCAD, but it's very difficult task. So simply, if I work with the Civil 3D, just I go to the point group label style and find out elevation with description only, label style, and press apply. In a couple of click, I will get my targeted point. So these are the things is very these are things very make our working style is very easy. So these are things, and also we can change our point styles also. In the Civil 3D, they provided some style for you. In the basic Civil 3D file, you can see some of the styles are there. Some basic styles are there. If you change one thing and press apply, you can change the style in this window. You can no need to press OK and go to the window, again go to the point group property, again change it and press OK like that. Don't do that. Just press OK, go to the point group property and change it and press apply, and you can see that simultaneously you can see the change in the window, and one by one we can change it, and we can easily change our point style also. And also you can see this is the point style. In the point label style also we can customizable as per our wish, and also the point styles also it is customizable as per our wish, but we are not going to discuss about the that things. You can see this is a price, it is called price tag button. If you click this drop down button, we can edit this current selection or copy this selection and make a new style for our point selection. But we are not going to talk about these things. So we are just stick with the basic styles come with the Civil 3D. So these are the styles come with the Civil 3D. We can use it. You can see some as per our point style and point label style, it will automatically change. This called point groups, points group. Okay, let's move to the second Civil 3D tool, that is called point group. You can see in our point list we have some. First of all, I need to change my point style to description only. Sorry. Basic description. Now I just move back to my previous style. It's very simple point marker with the point label. The point label only have the description. In the description tab, you can find my natural surface and also some trees are there. By using this draw description, I can categorize my point groups. Just think about, I only need the natural surface points without these 3 points. So I just only need my natural surface points as a point group. So to achieve that purpose, I just go to the point group and right click and go to the new. So new means I just going to create a new point group. So press new, and now we are going to give a name for my point group. So the thing is, I'm going to create a natural surface point group. So therefore, I'm going to give always remember, just give a meaningful name. If you just type XXX or SSS like that, it's nothing. It doesn't have any meaning. If you work again on your project, it will very messy. So always give a meaningful name. Natural ground. So I give a name to my point group. In this case, I will change my point styles also. So I am just giving the bound. If you want to check the preview of this point style, just click this button. If you go to this tool and just without click this tool, you can get a tooltip. So I will go and check this. You can see this point marker is with the square with the small circle. So if I satisfy this, okay, I will go for this. For a natural ground, for this bound point style. And also I go with the elevation and description only. Okay, and press apply. So now I created the natural ground point group, but I haven't add any data to this natural ground. So the only thing is by using the row description, by using the include tab, we can add our natural points into this natural point group data. So therefore you can see number match, elevation match, name match, row description match, and full description match. These are the things. By using these are the things we can include some points. So in normal case, it is grayed out. If I want to use this any option, first we need to click this one. If you click this one, this option will pop up. The first one is the row description. So our row description is NS. Before placing the row description, I'm just going to check with the point list. In the point list, you can see we don't have any points at the point list. So again, go to the include tab, and now I click this row description and going to I'm going to add the NS. It means the natural surface. So add type NS, and you can see in the point list, you can find each and every natural points data. Without our tree data, you can separate. We will separate our natural surface data from our whole points. You can see we only have the natural points. Then press OK. It's okay, but it will not change. So just type REA and press enter, and you can see it will change. If some AutoGet also have some issues. Sometimes if you change anything, it will not work on the screen. Just type REA and enter. It's regenerate all. Just refresh the window. But in this case, you can see we change these natural points, but it will not show off it will not show off the changes. So therefore, I use the REA, regenerate all. Then the screen will refresh. Then you can see all my natural points are changed, but you can see my 3 points are 3 points will not change anything. So easily we can work on this way. So we just finish our points and point groups, and also in the point group we can create the no display group. Like that we have efficiently used this point group, but we have only limited time, so we are not talk about these things. The next one is surface. For surface, you can see this point have the 461.22. This is the elevation at this point. Here 462 4 points. So by using this elevation, we need to create a surface. So how the surface is created? For normally, Civil 3D know about only these elevations. So by using this elevation, Civil 3D going to create a triangle. Like this, it will create some triangles. It's been normal our interpolation. This line is going from 464.22 to 462.22, and also this line is going 469.01 to 462. Like that, it will create a lot of triangles by connecting these points. After that, it will create a surface. It's just a 3D surface. It will create it. For example, So next we are going to move the surface. In this tab, you can see there is nothing. There is no plus icon is there. So it's mean there is no any surface at this drawing. So we are going to create a surface. So therefore right click the surface and create new surface. There is various methods are there to create a surface. We can use the digital elevation model, tin model, like that. We can go with lots of methods. By using the point cloud data, we can create the surface, but we are just stick with the basic. So just click the create surface and it will open up the create surface dialog box. In the type, we are using the tin surface. Tin surface means triangulation surface. By using the triangulation, it will create a surface for us. And also you can see surface layer, C topo. Our created surface will go into this C topo layer. If you are familiar with AutoCAD, if you open up the fresh drawing, you only have 0 layer only. But in the Civil 3D, you can find more layers. It's have 216 layers. These all layers are already set up. It's already programmed to why these all layers are created by the Civil 3D community, and they are created these layers for Civil 3D object. All our Civil 3D object are go and sit in one of these layers. So for example, you can see this one. Our surface object is going to sit at C topo layer. So that's why each and every Civil 3D object go and sit various layers. Okay. Then it asks for the name. So just I'm giving a meaningful name. Type EG, existing ground. If you are going to add any description, you can add it. And also it will, we need to give some style for our surface. If you click this one and go to the surface style, you can find some styles. These styles are come with Civil 3D. 1 to 5 background, contours, 1 to 5 design, 1 to 5. Normally we are using the background for our existing ground. For a design, we are using this design styles we are using for the finished ground surface. Finished ground surface is something we are designing. We are just planning the finished ground. It's mean the finished floor level of the building pad or something like that. We are planning we give this style to the we planned a surface. And this for contours and triangle size, and also it have elevation banding styles also have. So these styles are come with the Civil 3D. I am going to give the 1 to 5 background and press OK. If you are going to do any 3D model work, then you can give the render material also, but we are not discuss about these things. So then press apply OK. And my empty surface is created, just an empty surface. That surface has nothing. So we need to input some data onto this existing surface. Therefore, just click this plus icon again into the definition tab. In the definition, there is option called point group. So just click this point group and right click that point group, and you can find the option called add and press add. And in the point group data, we already have 2 points. The all points have all of our points. It have the natural points and our 3 points also. In the natural ground, we only stick at that natural ground data. So we are just going to add our existing data to natural ground point group data. So just click this point group data and just press OK. Now we are going to add our natural ground point group data into this surface. So now this surface has some information. Again, go to my interface and check it. You can check, you can find a smooth contours lines are there. You can see these contours lines are created by these points. But this is this style called contours 1 to 5 styles. You already know about the contours. In the Atlas book, you can find that contours and contours line, each lines have some elevation like that. each line have some elevations. So now I'm going to change this style to triangular style. So therefore, again, I already tell about it. If you select a civil 3D object, you can find related tools for surface. In this, in the previous session, we got the related tools for points. In this session, we can get our thin surface, the name of this surface, and you can get our related tools for surface. If you click with the surface property, and you can find the name and the surface style. In the surface style, I'm just going to change that style to contours and triangles. So press OK and OK. And you can see the surface is created by using these points. Each and every points, by using these points, the triangle is created. There is also contour lines. I'm just going to switch off that one. It is a style customization, but I'm not going to talk about this style customization. I just switch on the layer for triangles only and press OK. And you can see each points have a triangles. By using this triangle, the surface is created. But by working the civil 3D, it will create the 2D diagram, and also in the background it will create a 3D object also. To check the 3D object, just select the surface and go to the object viewer and press the object viewer. In the object viewer tab, you can find the 3D model. Just change the visual style to conceptual. You can see the 3D model. Without go to the side, you can find out in this area there is a lower point, in this area it's a highest point, and also there is a drop at here, and also there is a drop at here. Why? But without going to side, we can easily visualize our site by using this tool. Again, I'm going to change my style to 1 to 5 background and press OK and OK. There are more various ways there to create a surface. This is the one simplest method to create the surface. And we can do some analysis for this surface. So I'm going to talk about one of the common analysis for this surface is water drop analysis. So water drop analysis means if a drop of water placed at here, where that water will fall. So this is water drop analysis. It will very useful to create the drainage design, stormwater design. For that, it will very useful for the water drop analysis. So do that analysis, just click my surface. If I click my surface, the related tools will appear. Then press a water drop, and water drop dialog box will appear, and the path layer, where that path, water drop, where that created polylines need to. It means that it's simply that there is a layer where that created object need to go. The second one is path object type. If you need, we can create just a 2D line, or otherwise we can change it to a 3D polyline also. 2D polyline have only one constraint elevation, but 3D point, each and every vertex, it have different elevation. So I am happy to have this 2D polyline, and if I need to add any marker at a point, just press change this to yes and press OK. Now I'm going to place the water drop. If a water drop come at this point, it will flow to here. So like that, I just place some, you see, if a water is come at this point, it will go up, it will go to this point. So it means it is the highest point, it is the lowest point. So easily we can place a manhole at here. So all the water will come to this lowest point. So I will place a manhole and redirect that runoff water to somewhere else. So like that we can do a water drop analysis also for our stormwater purpose. So just click these lines and these two and right click and go to the select similar, then delete this one. After the analysis, just switch on that layer or just remove this one. We don't need this. These lines are just only for our analysis purpose. And also and also we can label this surface also. So therefore these points are we don't need, so you just click and go to the select similar and just hide these points. Okay. After that, if I select this surface, we can I can add some label to this surface also. So adding that label, click that surface and go to the add label tab, and I can add slopes. What is the slope for this surface, and the spot elevation, and the contours at single and contours at multiple. So I go with contours at multiple. At a time, I can give more elevation to my contour lines. So just pick the post point and it asks me to select the next point. So just I click the next point. It will easily place the label for my contour lines. You can see 406, 473, 72, 71, 70, like that. It in this side, the surfaces fall down. So easily we can get an idea about this surface by using these labels also. So it in Civil 3D, it will reduce our workable time. So, and also if I again select my surface and again go to the add label into the spot elevation tab, click this one and click somewhere in my surface to get the spot elevation. Just click at here and get the existing elevation is 466.57. This is the spot elevation at here. And also we can add the slope also. Just click the slope and just look at the command bar, create a slope label below. It will asking only for 1 point or 2 point, and go with the 2 point, and it will ask for a first point. Select the first point. So I select the first point and select the second point, and I click somewhere here, and you can see my rise over run over race detail minus 14.1 to 1. So I can add more labels, more various labels to my surface as per my need. These are the one more. We just create the surface and we can add everything as per our wish. So I just remove these things. This is all about the surface labeling. Okay, after we creating the surface, we need to create an alignment to get the cross-sectional view of our surface. So simply, you can, if you check the building drawing, and you can find out they will show up to you some cut section in the drawing. In this, like that, they will cut at here and show from here. So like that, they give a cross-sectional view. If you saw the building drawings or reinforcement detail drawing also, they just cut at the plan and show the how the cross-section look like. So in similar case, in if we need a cross-sectional, we need to create an alignment first. So in Civil 3D, they provide a name for that special name for that tool that is called alignment. We just place our alignment for a cross section. But in the different scenario, in the different field, they are using for different purposes. So in the road sector, this alignment is very important. They are give some restricted value by using, you already know about the ASTO code. The ASTO code give the geometrical detail for the alignment. It have some radius for that element, what is the tangent length for the alignment. So like that, all the things are defined in the ASTO code for the alignment. But if we go with that stormwater drainage plan, we haven't think about the geometric detail. We just on that time we just only need about the cross-sectional view. So the alignment purpose is different. For if you go with the road sector, we need to plan our alignment with the geometric, satisfy the geometric detail. But if you go with the stormwater or something else, if you only need the cross-sectional point of view, we just place it without considering the geometric plan. So just removing these two. So just I'm going to place a alignment. Just go to the alignment tab and create the alignment creation tool. So if you are going to create a simple one, just place a polyline, and now you can see in the AutoCAD properties window, you can find it as a polyline. Civil 3 provide us to make our polyline as a alignment also. So again, go to the alignment tab, into the create alignment from object tab. By using this tool, we can change this polyline to a alignment. So just after clicking this, tool, you need to check this command bar. It will show the first command. Select the first line. It means what will be the line you need to convert as a polyline. So first I click my alignment, and it will ask the second question. If you are going to press enter to accept the direction, it means you see that direction. The arrow is showing up the direction. It means at here it will place the zero chain edge. And it means at here it's 0. If I click the reverse, it will start here. So I am happy to start at here. So press enter, and I will get the dialog box for create alignment from object. First thing first, I just need to give the name for my alignment. I give the name, just give a meaningful name. Just I give the trial alignment. There are various types of horizontal alignments are there. First one is center line, offset, curbs return. Curbs return is curb return we are using for the intersection design. Offset means we just if we need to show the edge of the road, then we will use the offset alignment. Miscellaneous, if you are going to create a stormwater or something, we use this miscellaneous. And the railing, if you are going to do any railway track design, we use this trail. And also side. We are not giving any side detail to our alignment. The side details are important to create a side grading works. So in our session, we are not talk about the side grading. So I'm not give any introduction to about the side. And the next one is alignment style. In the alignment style, I already talked about it. Each civil 3D object have two things. The first one is alignment style, and the second one is alignment label. Object label style. Here also you can find the first one for the alignment style, the second one for the alignment label style. So first I need to, happy to provide this alignment style as proposed, and for alignment label I'm going to give major and minor only. and I just remove these two ticks. The first tick is add a curve between the tangent. It will normally place a 200 radius of curve in our polyline, but we don't have any curves, so this option will not be change anything. Erase existing entity. If I click this one, the existing polyline will be removed. So I'm not going to remove that line. So I need to keep it here. So just uncheck this box and press OK. Now you can see my alignment is properly labeled and it will create a alignment. You can see I will create a proper alignment. 0, 0 in the, it's a 20-meter interval. It will create an alignment and the alignment line style is a green color one. So if I need to change the alignment style, just click my alignment. If I click the alignment, I will get alignment related properties. Go to the alignment related properties. In the object style, I'm going to change the style. So I'm going to change the style to basic and press apply, and you can see my line color is changed. If I'm going to change the existing one and press OK, and my alignment styles become red color. So like that, we can easily change. And also, if I need to change my label set, I click my label and right click and go to the edit alignment label. In the alignment, these are the three important stuffs to create this labels. So if I need to change my label, I'm going to create import label set, and it will show a small dialog box. In the dialog box, I am going to add this one. It's a different style, and press OK. And OK. And you see, it will give up different styles. And not talk about the creating a new style. Just I am changing the styles. It's already created. So by using this one, I am just converted a polyline into a alignment. This is the very simplest method. First, you place a polyline and you just convert this line to a polyline. Okay, so this very simplest one, but in the stormwater design, we can do this method. But in the real case, if you are going to do any road design works, we need to use this alignment creation tool. Here are more tools are there. One tools used for another different purpose. It's totally depend on our purpose. So if you don't consider about the geometric detail, just go with this create alignment from object. If you are consider about the geometric detail, go with this alignment creation tools. So this is have some design restriction by using this tool. So just click these alignment creation tools, and it will ask it will open up the create alignment dialog box. In first case, we need to add a name for this create alignment. I'm just give a name for trial alignment, and its a type is center line. That's perfect. We are not going to give any side to our alignment, and also the alignment style also proposed. That's now in this case, I'm going to change this to, I keep it to proposed, and our alignment should go to this C road layer. If I want to change this layer, just click this layer button and click this one, and it will show the layer selection dialog box. If you need to change anything, just press it and press by clicking the press, it will change the layers. So we are not going to do that one. So just keep that layer to C road. And next up, alignment label set. In the alignment label set, we are going to give major and minor labels only. We are using these types and press OK. And you can see some flyover toolbar. It's the same. This is the same flyover toolbar for the point creation. So this kind of flyover toolbars has in left side to right side, the point tool complexity is increasing. So these tools are more easily we can accessible, but go in this way, it will have some difficult tools. So you I think you see my picture now. In this picture, you can see between the two tangents, we are going to create a curve to make the connectivity to this line. So the start point, if you have studied about the highway design engineering subject, then you will know about this picture and know these terms. The first one is point of curvature. At this point, if the curve started here, that point is called point of curvature. This point called point of intersection. It means we need to place a tangent at point of curvature, this point of tangency. We just place a two tangent and it will intersect at point of intersection. This is called the curve. These are the so we have some more equation to find out what will the t and I and this length and everything. We have some equation to find out. In our lecture time also, we are just using the calculator and we just find out these values. But in Civil 3D, we don't need to spend any time to calculate those values. Simply, we just need to draft our alignment. The calculation part, Civil 3D will automatically provide to us. So if you are going to change any, if you are going to do any changes, no worries, the Civil 3D automatically calculate that values also. So I'm going to create a curve alignment. Therefore, I'm going to, before I'm going to curve, I'm going to create a tangent with no curve. So you already know about the tangent with no curve by using this tool. Just click the tangent. I'm just going to draft my alignment. Just press escape. I will got my alignment. You can see by using the tangent, I easily created a alignment. You can see it is a trial alignment, but for now I'm going to remove this one. Again, go to the alignment. Again, go to the alignment revision tool and accept the default. And now I'm going to this and come to this tool and using the tangent with curves. Before using this curve, I come to curve and spiral. In the curve tab, you can find the curve radius is 200. When you're placing a curve, the curve radius should be 200. That is the thing we can define at here. For now, I'm going to give 150. My curve radius should be 150. So normally we are doing our alignment with line and curves. We are not created any spiral or spirals. We are not provided any spiral in our design. In the expressway, we are planned to spiral curves. So for it's more than enough to create a road design Sri Lanka for by using the lines and curves. So I just press OK. Again, now I define the curve radius as 150. Again, go to the tangent with curves. So by pressing the point of intersection, it will automatically create a curve for me. So just create, just clicking that tool, and I'm just going to place my alignment. It asks for a first point, click my first point and go up to here and go like this. In this graphics, you can find it will show up a curve for me. As per my next point, it will automatically change a curve. As per my point of intersection, the curve radius also is changing. So for now, I'm going to click at here and click at here. Now I place my alignment with the curve. So if you are going to see the curve detail, just click this curve and click this green color button to get a tabulated form for the curve details and the line tangent details. Just click it and you can see all the you can see all the details. Line curves. I add line curve for a continuity purpose. My horizontal line alignment continuity purpose, I created like this. In this case, you can find my curves. In the type curve, you can see all my curve radius are 150. So I will perfectly add a curve. By using this method, we can simply place a alignment. But this can only if you are going to do any new development in a large area, we can use this kind of method. But in the city is already developed like that. This set is already developed, like our rural roads. Our area is already developed, but we are going to do the correction in our roads. It means we are going to overlay our asphalt, or we are just place some gravel on the layer. On that time, we can't change the existing center line. It means just think about this is our existing center line of the road. In this time, we can't change this existing center line because this in here we have already some houses. So we can't break this center line. So we need to follow this existing center line. On that time, we can't follow our AASHTO codes. So we need to just follow our existing center line. On that time, on that kind of similar type, we need to go for a different tools. Just go to the alignment and press the alignment trial one and press OK. On that time, we can't use these tools. So again, we need to move here and just I'm going to fix line. So I need to create lines as per my center line. So just think about this is my center line. So one by one, I'm going to place my horizontal alignment by using the line tool. In this case, I just place the line without any curve. So now I'm going to add a curve. So for that, just go to this this curve icon and go to the free curve with fillet with two entities. So try to select this option and click OK. And it asks for the first entity. You can see in the command bar, it is showing the first entity. Click the first entity and the second entity, and you will get a curve. So as per your wish, you can graphically change the radius of your curve. So if I satisfy at here, I will click at here, then I will place my curve. So there are option to manually edit your element also. So just press here and again go to the tabulated form for my curve. In this curve, you can find first I have the line, second I have the curve, and third, fourth I have the line. I'm not changed this these two with the curve. So in the curve, we can check our radius, and also you can see some more details also there. You see the delta angle, the short length, the clock, the degree of curvature, like that. We have all information about this curve. We can get all this information by using this window. If I need to change this radius, you can see my curve radius is 489.853. I need to get this as a round value. Just double click on this radius. Sorry. Before edit this value, you need to unlock this curve. So just click this lock button and go and double click it and place 500. And as per this value, all the value will change. Okay, so no, as per our values, if you are not satisfied 500, you can insert another value and it's automatically changed. So no need to each and every time we need to calculate these values. So I just place a 500 radius curve on this particular area. So as my wish, we can manually edit my horizontal alignment also. So after placing my horizontal alignment, after talk about the profile, we go for a 10 minutes break for me. Okay. Yeah. After creating the horizontal alignment, we just click my alignment and we are going to create a profile. Simply profile means it's a cross-sectional view. Just think about if it's a profile means it's a cross-sectional view. So just click my alignment into the alignment and you can find some option in the launch pad. You find out the surface profile. So just click this tab. You can get this dialog box from this way, or in our home tab you can find we talk about the alignment, and next one is profile. So drop down this one and create surface profile, the same option. So create surface option, surface profile. In this alignment tab, we need to select our alignment. So in this case, we have two alignment. That's why it is show up the two option. So I go with the first option. If you are not confident with your what we are going to select, just click this green color button and you can click that your needed alignment. Just click this one and its name is trial alignment, and this our surface. If you have more surface, it will appear at here. Now my alignment is perfect, my surface is perfect. Now I can eligible to create my profile. Just in this profile list, we haven't seen any list. So I need to press add to sample this surface. By using the alignment and the surface, I provided a sample surface. You can see my sample profile list is created. If I click the add, my profile is created, but I haven't created my profile view. It means in the profile, you can find two objects. The first one is the profile. Profile means the vertical elevation of our alignment. The second one is the profile view. Profile view is just a graph. It's just a graph, grid lines. That is called profile view. So in the first case, if we press the add, it will create a profile for you. If you press OK, it will create a profile for you. But the profile, if you are going to show your profile, we need to have a profile view. So therefore, again, go to this create surface profile. You can see I already created my profile, but I don't have any profile. So therefore, just click the add in profile view. Now, these are the steps. If I properly give the proper things to these things, then I will easily create my profile view. First is ask, again it asks for alignment. Okay, that's perfect. It will ask for the profile view name. So I'm going to give EG. Press OK. And profile view style. So every civil object have two styles. So it will ask a profile view style. It have some style. It's come with the Civil 3D template. So I'm going with happy to provide the profile view styles. And the profile is go under the C Road Pro profile view layer and press next. The station range is defined from alignment. It automatically take the start and end values. If you are going to change any different values, you can manually edit it here. So for now, I don't need to edit that one. So just go to the automatic. And also it will have the profile view height. It automatically take the lowest and the highest value. If you are going to manually change this value, you can change it. The graph bottom and the top value, minimum and maximum. In the station range, we customize the X range value. In the station range value, we just customize the chain edge, the X direction value. In the height view, we just change the Y direction value, the start and end values. Profile display option, in this display option, it will only show up the existing ground for our alignment. Data band, you can see it will show up a red color line. Under the profile, it will show some data related to our profile. It has some styles also. If you need more style, you just change it. I just happy to provide the ED and FG and press next, and you can see create profile view and press that button, and it will show create a profile view origin. It will ask for the location to insert the profile, and just go and provide insert at here, and you see this XY direction called the profile view. If I need to change that one, just click my profile and go to the profile view. And we can give more styles to our surface. So likewise, we can change it. This style is pretty good. So I have also this one. So you can see in the Y direction is automatically provide the all details, and also you can see in the ground data at 0 station, what will be the existing ground elevation. At 020, what will be the elevation for existing grounds. Like that, it will tabulated for the existing ground details. And also, if you need any different points, you can drop a line and find out elevation. Or it have more add label tool also. By using that tool, we can find out it. For example, in 20-meter interval, we can find out the elevation. But between that, between a point, we need elevation. Like that, I need a, you see, for a 40-meter chain edge, I have the existing elevation of 450. But I need the elevation for 30 meters. So therefore, I just click my profile and add a data. So therefore, I go to the add profile view and station elevation, go to the station elevation, and it will ask for the profile view. So I just click my profile view and it specific station, it asks for a station. I just type 30 and press enter. So it's automatically locate the 30 and I just need to show the elevation. So just come and find the nearest point and press it. Okay, then automatically easily I can find out the at 30 at 30 the existing elevation is 450.39. So by using this method we can easily find out any elevations from a profile. Extraction. Okay, so as we discussed early, this is called profile. You can see profile. This one is profile view. So two different objects are at a single frame. You see that one is profile, this one is profile views. So these two things have different customization options also. So this heading, this text, this text styles, text font, text style, everything we can customizable. So we are not going to discuss any customized detail at here. So we can get the existing ground detail. So after that, we just placed our existing ground detail, but also we need to place our finished ground detail, finished ground profiles also. So therefore, just click the profile view and go to the profile creation tools. If you click your profile, it will show up the profile creation tools. Just click this profile creation tool. It will show up your profile creation window. And we need to give a name. So I just give a name for trial FG. FG means finished ground. Just happy to provide the design profile. And also full label sale also perfect for my profile label. So I'm press OK. And you can see some same flyover toolbar here. By using this toolbar, I can just create the finished ground profile. So using the knowing that, just click that one and draw tangent with curves. So click it. You already know about these tools. Draw tangent with curves. By using these tools, we can place a curve with our tangent. So just click that tool and always remember to start at the 0 point and end at the last point of our alignment. So just click the start point and we need to draw our finished ground. By creating the finished ground, it have different scenarios are there. Some clients are always expecting the create a finished ground with the cut and fill volumes need to be equal. Some client expecting I need a perfect geometric detail for my finished ground. So like that, it's totally depend on the client requirement and also our working project expectations. So for now, I'm just using the basic tool. So click this one and you can see the automatically place a curve and click at here and click at here and click at here and end at here. And it automatically give the labeling works also for my finished ground. And also by using these scripts, you can manually edit your profile also. You can see this is called intersection point. Our picture says these 2 points go and meet at a point that is called point of into the same points. So if I click that one, if I need to change my point of intersection, you can move it. And also, if I change that point also, we can easily move it. Like that, we can easily change our finished ground profile by using these scripts points also. And also again, you need to go to the profile tabulated format. In this format, you can find each it be tabulated for PBA station elevations. At the station elevation, what will be the elevation for that PBA points? What will be the grade in and grade out? These values are in the percentage. Okay. Then if you are going to change the radius of your curves, you can easily come here and radius. Yeah. The K value, you already know about the K values and the radius. In the radius tab, you can easily change that values as per your wish. So I'm just going to give a round value 1750 and percent, and you can change it as per your wish. So it will reflect in your design also. So this is for profile creation. We can call it as the vertical alignment design also. Okay, now we end up with the vertical alignment. We need to talk about the cross section and plan production going. After that, we end up the session. For now, I'm going to take a 5 minutes break. So I will come back and do this, continue this session after 5 minutes. Thank you.
Dear participants, stay tuned. The session will be starting at within 10 minutes. So stay tuned for more updates.
Thank you very much for your patience, and again we will start our session now.
Yes, sir.
And you
Yes.
see in the design create design tab, you can see parcel feature line gradings. So these things are not in our course session, because these things we need to talk about separately, because parcel, normally this tool parcel is used to create the subdivisional plans. The subdivisional plans means we need to just divide our bigger land as per the land area requirement and the building coverage. So this tool is dedicated for that. And this feature line is simply we can call it a civil 3D 3D polyline. Is by using this polyline, by using this feature line, we can get more information about information about the line editing and line editing in the 3D. Line editing in the feature line. You see in the modify tab, edit geometry, edit elevation. These are the tools which is dedicated for this feature line. So feature line is more give option to us the edit the lines. So these feature lines is used to create the grading purposes. Grading means we are just giving the terrain, existing finished ground detail to the our client to easily drain our stormwater to the river or our existing stormwater network, or like that. We need to create a grading, that is called grading. So so these are things more advanced, so we are not going to talk about this. And also you know about the traverse. We are not going to talk about the traverse also. By using the survey editor, the traverse work and give the information by point. By using these tools, we can just get the misclosure error. By using this misclosure error, we just easily divided that misclosure error to each and every point. So Civil 3D makes our civil engineering lives a bit more easier. And these, now these are the things. And we already talk about the alignment profile, and we are going to talk about the corridor. To create a corridor, first you need to have the alignment first. Second one is the profile. Third one is assembly. Simply, corridor is a 3D object. To create, if you are going to create a cross section, first you need the corridor. If you create the corridor, you need the alignment, profile, and assembly. If you are going to create a profile, first you need the alignment. So each and everything has a interconnection between us. So first if you need to create a cross section, you need the corridor. If you are going to create the corridor, you need the alignment, profile, and assembly. If you are going to create the profile, you need a alignment. So likewise, each civil 3D object has some interconnection. So to create a corridor, let me introduce the assembly. Simply, we can say the assembly is the road cross section. Simply, we can code the cross section view. So go to the drop down and create assembly and click it and give a name to DW. Or you can give any name. I just give the give a simple road assembly. I just give a name, a simple name, assembly. If you need to give any description, you can give it. It will not be affect your design. and assembly type, and this is for assembly style and code stress style. The very important thing is code stress style, but we have very restricted, so we are not going to talk about the code stress style. Okay, then press OK and click here. Then our assembly we inserted at here. So after that, we need to add some sub assemblies. This is called assembly. It's just a single line. We need to insert some sub assembly parameters. So therefore, we need to go to this home tab and you can find this tool palette. If you click Ctrl+3, you can access to that tool palette. Just click that tool and can find. In the tab, I just click at this end at this point and I found the lane. In the lane tab, I click the lane lane supervaluation arrow. It has more sub assemblies are there. You can see if I click here, it's just categorized lane wise, solder wise, median wise, curve wise, daylight wise. It will categorize some more tools are there. More road sub assemblies are there as our wish or client requirement. We just create a road cross section as our wish. So first I need to place a lane. In the lane, we have more options. So therefore I'm going to lane arrow. I just place at here. Okay, I just place this my sub assembly. In the sub assembly, you can see some yellow, a dark blue, light blue colors are there. It's the layers thickness. Normally, if you are going to provide a lane, first we provide a pave one layer. It's a bind layer. Second one is a bearing layer. Third one is a base layer. The fourth one is sub base layer. Like that, it will categorized. So if you are going to know about this layer thickness, we can change it. If you click here and go to the sub assembly properties and again go to the parameters, you can see pave one. Pave one means the paver means the bearing binding course. The second pave 2 is bearing course, the base depth and the sub base depth. As per your payment design report, you can change it, and also you can change the cross slope of the road also, and what will the width, and also you can customize as per your wish and press OK. I just happy to follow the defaults. Again, now I place the lane. After that, I am going to add the daylights, or before that I'm going to add a shoulder. So I'm going to come with the shoulders and go with shoulder extent and press OK. Sorry. Now I add the shoulders, but I think the width of the shoulder is too high, so I'm going to reduce that one. So I just place my shoulder width for 1 meter. And also I need to change the slope. So I'm going to change that slope to 2 to 1. Okay. So now I place my lane and the shoulders for a right side. I need to mirror these two components for this left side also. For that, just click my lane and the shoulders and go to the mirror option and click that mirror. And I just need to select the center line of this marker to mirror that object. We can easily get that road cross section. This line called assembly and each component called sub-assemblies. By compiling the each sub-assemblies, we can get an assembly. So now we created the assembly. My assembly name is, by clicking the center line of this assembly and go to the assembly properties, simple road assembly. This is my assembly name. Okay, now I am eligible to create the corridor. Again, go to the corridor and drop down it and click the first icon as corridor. I need to give a name for my corridor. I just give the name as FG. Finished corridor. If you are going to give any description, you can. And style is basic. And this is the corridor layer and basic type. The type you can see, the first option is setup. The first option is called alignment and profile. Normally, the alignment only have the, it's a 2D plane. The alignment is a 2D plane. The profile is the, it will show the alignment elevation. That way it will show alignment and profile. In the feature line, I already told you, feature line have the 3D elevation with the line. That's why in the feature line, it will show only the feature line. I hope you understand. Normally the alignment is a 2D object. It don't have any 3D elevation. So for the 3D elevation, we just add the profile. In the feature line, we have 2D and 3D elevation also. That's why in this case, in the second option have the only one, but we are not using the feature line. We are now go for this alignment and profile. Our alignment is trial ALG. For trial ALG, we created a finished ground. That finished ground is trial FG. Okay, so click that one. And our assembly, they ask for assembly. What will be there? What will be your cross section? I need to run. So just select my assembly. And also it will ask for a target surface. What is going to happen is, this is my center line. This is my center line of horizontal alignment. By using this center line, this assembly going to run at this center line. For that, this assembly is going to use this this elevation, the finished ground elevation. Is totally depend on us. If you are going to run with this existing ground elevation, we can, but we always run our assemblies for this finished ground elevation. So our each assembly is going to place at this finished ground and need to run this elevation. So that is going to happen by using the corridor. So again, I click the corridor and press corridor option and give a name as corridor. A description, okay. Style, okay. Trial, okay. The profile, I need to change the trial FG, and the assembly is simple road assembly, which is I created already. And in the target surface, if you are using any daylight sub-assemblies, you can give the target surface. Otherwise, just keep it as none. So just press OK. It will show up another window. In the window, you can see that is called corridor creation window. This window, my horizontal alignment is here, trial FG, and my vertical alignment is trial FG is here. My assembly is here. So all the things are listed at here. And by pressing OK, it will add my corridor. You can see it's perfectly added my corridor. By clicking this one, by clicking this corridor and go to the object viewer, you can see my 3D road model. Easily you can find my road. My road have the land with the shoulders, 1 meter shoulders and around 8 meters of land width, it will perfectly created. So again, I just close this one. Okay. And you can see, for your knowledge, you can see some pink magenta color lines are inserted at here. These are, you can see, you see, these magenta color lines are called our cross section, which is created at here. These assemblies are inserted at here, at here, at here, at here, like that. We can this called frequency. If you need a more accurate and smooth curvature detail, we need to increase the data. Normally, for a curve detail, you see this line is not a curve one; it's a lighter straight line. For this assembly, it's just a straight line. So if you need a more accurate data, we need to insert more assemblies. So therefore, just click our corridor and go to the edit frequency tab, and need to select our region. To ask for the select for region, I just select this region. In the region tab, I just come and along with the vertical curve, I just need to change this value to 5. Then I just give an instruction to provide 5 meter interval, just add a assemblies. In the previous case, I inserted into 20. It's a default value. Now I need a more accurate data, so I just go and give the 5 meter. Now you can see I will get a more smooth and more accurate data, but it will reduce your computer performance. It means while you are working on the civil 3D, the civil 3D workability will be reduced if you are using the more smaller values. So keep in mind. So now we have created the corridors, and you will get idea about this assembly. Now you can see in the previous case we have two assemblies, but now 1, 2, 3, 4 like that. We have insert more assemblies. For knowing that, just click that corridor and go to the object viewer. Just change the style to 3D wireframe. You see. In the closer look, you can see the assembly is inserted each and every 5 meter interval. By compiling those things, that 3D surface is created. Okay, that is happening in the background. I just close this object viewer, and also if you are going to select anything in the corridor, it will totally select the whole object. You can see it will not be. We can't select a particular object. You see, if I go near to this green color line, it will show a corridor feature line. So what happening in the background is, by using these assemblies, the corridor tool need to create a feature line throughout this assembly. That's why these feature lines, you can see there's more objects are there. These lines comes from by corridor 2. Okay, if you are after that, just click this corridor and again go to the corridor properties. you can see some more tabs are there. In the tab, most common used tab is surface. By using this, we are going to create a surface by using this corridor model. To do that, select this button. If you go and just hover your mouse on this icon and create a corridor surface. So we are going to create a surface. So just press this one and it will show up a corridor surface. But in this detail we don't have any details. So therefore we need to add some detail for this surface. So therefore click the link and we are going to click the links and press top, specify, keep it in the top and press OK, and we are added a detail into our surface. If you are going to change the name and just change this, simple. Now we added a surface, and also we add a specific code. Then press OK. The corridor will be rebuilt, and you see what is the top code mean. It means using these this is the top code. You can see this is the shoulder endpoint, this is the lane endpoint. By using these point, we are going to create a surface. So that's the thing is there. You can see I added a surface in the top bar in the specific code. By using the top codes, we are going to create a surface and press OK. Now we have created a surface. In the tool space, you can see a new surface is added, but you can see the icon is different for ET and the road sample, because you can see in the road sample you see some road model, because this road sample is created by using the corridor model. That is the thing, it is indicated in this icon. So now everything is perfect, and click our surface. If you click your surface, our surface is went somewhere. You can see in this point we don't have any detail, but our surface is created. So we need to restrict our surface up to this line. So therefore again we are click our corridor and go to the corridor properties, and in the boundaries tab right click the road simple our corridor and go to the corridor extended as outer boundary. It's just limit our surface up to our outer boundary. Then click this option and press OK and rebuild the corridor. Then our surface is limited to our outer boundary. That's fine. Then click this, click our surface and go to our object here and check out our surface. So I just need to change the conceptual method. Okay, see perfectly my surface is created. You see a small cross slope for my road, and there is a forward slope for the field slope for the shoulders. Okay, that's perfect. Okay. The intersection is something is more advanced tool. If you're going to understand this intersection, you need to familiar with this all alignment, profile, corridor, and assembly. Hereafter, you can understand this intersection. Otherwise, it is very tough to understand this intersection. Normally, intersection means just think about this is a road A, this is a road B. We are going to place a intersection at here, by using the corridor tool. So all the things are need to be same elevation at here, but corridor model something is more different. We have some idea about the 3D one also. So for now it is very tough to understand the intersection. And also if we change the window to 3D, all our details are served in the 3D one also. I just switch back to my screen to 3D. In the 3D window, you can see all my details are in 3D background also. In the point, I'm using the 2D wireframe. If I want to change my to shaded view style, you see my road and the existing surface are in the 3D elevation also. So this is one more advantage of Civil 3D. You can go back to my previous one. Okay. Then the last thing is for creating the cross section. After we creating all our surface, finished surface and the existing surface, we are going to place some samples line. Sample lines is important to create the cross section. So just click the sample line and it will ask for the select the center line. So I'm going to select my center line. Sorry, center line means the alignment. Click my alignment and I need to place my sample line. Sample line is nothing but is same as the alignment. Is we are to get this vertical profile, we are just place the horizontal alignment. For getting the cross section, we are going to place lines like this. We are going to get the cross section at these points. We need to place the lines like this. So these are line called samples lines. Is just a cut section. So but Civil 3D has a dedicated tool for that. So sample, which is called sample line. So click the sample line. And first we need to select our alignment, which means our sample lines is placed based on our alignment. So just click my alignment. Give a name for my sample line set, and same concept. Sample line, each Civil 3D object have a sample line styles and also label styles, and also it will automatically set to a one layer. And okay, if I need a specific cross section, I will by clicking the mouse, I will provide a sample line. But in each 20-meter interval, I need to place a sample line. So therefore, I am going to by station. By range of station, and there will be a dialog box. In the dialog box, I need to change some settings. That's it. So width, you can see in the left, swap width means what will be the width of left hand side. If you give 20 meter, it will cover 20 meter of cross section detail. So if I give a 10 meter, it will cover only the 10 meter cross section detail. So I just give the 12 meter. So it will cover the 12 meter cross section detail. Same for the right side. And also give me a sec. Okay. Here are 20 meter, 20 minutes. I just provide the 20 meter interval of sample lines and press OK. Yeah. Then you can see each. Now I added my sample line at each 20 meter interval. I just added the 20 meter interval. These things comes with the sample line labeling. If I don't need this labeling, I just click it, and if you click the one label, it automatically select the whole labels. So I just remove the whole label at one shot. So I just remove the sample line labeling, but I have the sample line. To create the cross section, and go to the sectional view and create multiple views. By using this create multiple view, at a time we can create the more cross section. But if you need only one section, create a section view. By using this section view, you can create only a one section view. But I need the more I need the every cross section. So therefore, click this create multiple views, and it's come up with a dialog box. And first thing is, okay, first I'm going to select the alignment, and second thing I need to select the samples. It means sample line means it is the sample line group set, which is I named as sample. If you need to reduce your cross section details, you can change it. So as of now, it's defaultly take 0 to the end station. If you restrict your station, you can change it here. If you need to change the custom view name, click this button and come here and you can change it, but I'm not going to change these things. And also in the section view style, you can change you can give any style for, because we have two styles. So I'm going to give the road section. In this tab, if you have the properly set the title block with a title block, if you properly set up with the title block with the scale, then you can use this plan production drawing. If you are not set up anything, just provide the draft. Normally these works are done by the drafters, plan production drawing. But if you have more interest about the civil 3D, just go and search the plan production drawing, and you can get the idea about how the drawing output will set up. So for now, I just create the draft and press enter, and I just review the left width and the right width for the cross section detail. That's perfect. Elevation also perfect. Press next. Next, in this detail, they are going to give me in the section display option, it will show up existing detail and corridor detail and corridor door details. This means the corridor means corridor means it's a corridor object. The corridor road sample is a surface object. So they are going to give 3 objects. If you don't want any object, just click this icon. It will not be shown. So enter. But also we can add some band also. If you don't want anything, just press no band. It will not be show any bands. If you want anything, just I go with major station or something. And okay, then again we need to show we need to give a location for our cross section. Just I give here. Then you will find a cross-sectional view for our existing elevation and our corridor. But it is not properly set up because of the scale. If you change the scale a little bit, Yeah. Then you can got this kind of diagram for each. You can see each 20-meter interval. Sorry, here 20, here 40, 60, 80, 100. 140, 60, like that, it will increasing. So as a one shot, we can create the each 20-meter interval road cross section. So it is a very easiest easiest tool to use. And also it has some more customization, but this cross section is very, how can I say, very low quality format, because we are not using this kind of styles in real practice. We have just customized these styles and give a proper styles to get a better look for our cross section. For example, it's a it's a real road project. You see that corridor, and you see some point group which is added to this plan. And also you see the profile, and this profile has more information: station, finished ground elevation, existing ground elevation, and also it has the vertical and horizontal geometric details also, and also it have the super elevation details also. And you see, this is by using this existing these details, this designer just customize the existing styles of the civil 3D and just manipulate it. And by manipulating the design, I created this kind of setup. These designs also same like that. And also you see, I already in the earlier stage, I told you this window only for drafting. By using this window, we are going to make our printable output. So we are just give the type of idea about the client by using these kind of sheets. You see, this for the plan sheet, this for the profile. This is called plan production drawing. Only in civil 3D it will produce this kind of plan production drawing. It has some dedicated tool to create this kind of paperwork. But we don't have enough time to discuss about the plan production things. But I think it's nearly take 2 to 3 hours to discuss about things. If we have time, just go to YouTube and search for it, a plan production for it. You can see that in the output tab, you can see that it's have a dedicated tool for plan production. By using this tool, we can easily print out our plan profile drawings and cross-sectional drawing also at a one shot using the plan production drawing. Okay, I hope I try to cover maximum of which I can able to. If you have any questions or any queries, please ask. Thank you all of you for your time. If you have any questions, please ask, or otherwise we will close this. We'll wind up this session.
Participants can shoot your questions in chat box. Chat box is available for your questions now. If anybody have any questions, you can unmute yourself and ask also.
I hope you all of you understand my session. It's pretty happy for me. And thank you for all of your time. And thank you.
So thank you so much. So one question, please. One question from audience that how this software is more applicable in the industry, and they're asking for to master or to expertise in industry, how to proceed this. It's a general question.
Yeah. Normally we are studying around 4 years of degree. After 4 years of degree, in the 4 years of degree, we did more calculation, manual calculation and everything. But in the real practice, we are not going to do any manual calculation at all. So try to do not civil 3D. You need to learn any softwares to how the industry is developing. You need to know any structural software or civil 3D software or any geotechnical software or any hydraulic software, head crash or like that. You need to learn. After your 4 years of study, your study is not end. So you need to study each and every day. So you need to update yourself. Otherwise, your juniors or your higher position seniors will just overtake your knowledge. For your question, in the real practice, I will show some examples to you how this software works. I hope my screen is, the PDF screen is visual
Yes,
for
sir,
you.
it's visible. Yes.
Yeah. In this, by using the Civil 3D, first we design, my purpose to using this to design the road. I got a highway engineer job, so therefore I need to plan this. So I just create this plan production drawing for our clients. And also I just create this kind of cross section, each and 20-meter interval. Clients are expecting how the road will behave. So we are just going to draw this cross section and add the labels. You can see what is the cross stop, what is the cross stop show for the shoulders, like that. For road sector, we can do any works in Civil 3D. And also we can draw the culvert cross section, culvert designs in Civil 3D also. We are using this culvert design for just find out the finished ground elevation. But the another thing that just follow by the AutoCAD drafting. For more now. After that, it's a stormwater project. You see in the picture, it's a parking lot. We can design the parking lot by using the Civil 3D also, but we need to add an extension. You see the lines works are there. These lines works are automatically created by using the Civil 3D. We just need to give the parking lot width and length, then it will automatically create the parking lot. And also you see this contour lines. So first this is a residential project. First we'll buy a land. After that, we just do the topographic work. After the topographic work, we just place this road. It's the proposed road. After propose this road, we are just plan to add the stormwater design. Normally, we just place pipe and manholes to discharge this runoff water to a detention pond. I think you all know about the detention pond or any water. So we can create the pipe network drawings also. The pipe network drawing, which is useful in the water, in Sri Lanka water board also we can work. So by knowing the Civil 3D, we can work in the RDA. By knowing this stormwater management, we can work in the water board. And also, this is the elevation view of the pipe. You see this pipe, and this is the manholes. The existing elevations of the road, and this is the finished ground elevation. This is the pipe network. And this one for the bridge project. This bridge project, you see there is these contours are reducing at this side. By using by knowing this one, we are just planning to place a bridge. This cross section detail is created by Civil 3D. After that, we just place our bridge. The bridge structure detail is not, we can't analyze here, but we just confirm the elevation without any flooding condition, without any disturbance for the bridge. We can finalize our finished elevation for our bridge. Here's also bridge project, and this one for the irrigation project. By using this, this is a tank project. In the tank project, they sent the drone to above the tank, and they got the contours data. By using this contour data, we can find out what will be the capacity of this tank. These are the details we can easily find out by using the Civil 3D. So by using this contour, we can find out what will be the capacity of the tank. So after that, we just think about what is the expectation of the water requirement and what amount of water we have. So by comparing these two values, we just know we need to improve that tank or not. Like that, this kind of detail we can interpret by using the Civil 3D. So this work for irrigation. So irrigation department, water department, and RDA department, and also even in the building department also, they just have a bare land. In the bare land, we need to place our building pad. So there should be a cut and fill should be there in the land. So normally in the building department, in the building side, they are using civil 3D for cut and fill requirement. What will be the cut and what will be the fill for that particular site. So cut and fill details also we can do. You can, I'll show an example for that. It is a warehouse. In the warehouse, we have the existing terrain detail, and also we have the finished ground elevation also. By comparing these two details, what will be the cut, what will be the fill? You can see EG means the existing and BLDG means the building. By using this much of cut is there for the building, this much of fill is there. So totally it have 668.1 cubic meter of cut to do this site. So we can easily provide a proper estimation to the contractor. So contractor to estimate that value. So like that, it have more opportunities in the civil world. And also it have the turning radius also. After designing the road, the car should be turned to our driveway. So we need to create this kind of plan. But in Sri Lanka, we are not going to create this plan. It's a foreign job. They are just provide a driveway inside their house. Inside their house, their county. Council means the municipal council. Their municipal council ask us to how a car come through the road and without touching anything, it will flow, just turn into a driveway. So like that, we need to submit this kind of diagram to get the approval from their county. So there are more applications are there. So I hope you will get the answer from your question. Any more
Yes,
questions?
sir. Thank you for these kind informations and these elaborated examples and for the clear explanation. Any more questions from audience, please? If there's no questions, then let's move for a little Thanksgiving moment. And thank you so much, sir, for conducting this event successfully. Over to you, Sajeevan. Please take over.
First of all, I want to thank Engineer P. Shrijen for this wonderful session for us. When I asked him for this session, without regretting, he accepted to do this for us. I hope everyone utilized the session and it will be helpful for you all. Finally, I want to thank all the participants and the organizers who helped me to do this event. And if anyone from the audience want to learn the complete course with his complete guidance, you can contact him. The contact number is in the chat box, and his industrial experience also will help you more to understand the software. And also, he is not only working in Sri Lankan projects, he's also working in abroad projects, Canada, UK, and Dubai projects also. So it will be helpful for us and all. Thank you for all. Let's wind up the session.